Hi, and welcome to Ferris wheels, using trigonometric functions to model cyclical behavior. Sounds like fun, doesn't it? All right. Ernesto thinks that this is the graph of f of x equals 4 sine x minus pi over 2. Danielle thinks it's the graph of f of x equals 4 cosine x. Who is correct and why? Well, in looking at this graph, it appears to start at an amplitude down here, except it's at a negative amplitude. So it can't be a positive 4 cosine x. So that means it cannot be Danielle who's correct. So it has to be Ernesto. So Ernesto is correct because sine starts at 0, 0 normally. And if I take and I translate my function to the right, because that is the direction, oh, that's weird, the direction I'm going when it is a positive. If I take this point and I move it to the right, pi over 2 units, that's where I end up. My amplitude is 4. Therefore, it's got to be Ernesto's graph. So, keeping that in mind, we have a carnival has a Ferris wheel that is 50 feet in diameter with 12 passenger cars. When viewed from the side where the passengers board, the Ferris wheel rotates counterclockwise and makes two full turns each minute. Riders board the Ferris wheel from a platform that is 15 feet above the ground. We will use what we have learned about periodic functions to model the position of the passenger cars from different mathematical perspectives. We will use the points on the circle in the diagram to the right to represent the position of the cars on the wheel. All right. So, keeping this picture in mind, whoops, went too far. For number 1, for this exercise, we will consider the height of the passenger car to be the vertical displacement from the horizontal line through the center of the wheel, and the co-height of the passenger car to be the horizontal displacement from the vertical line through the center of the wheel. So basically, we're just looking at this Ferris wheel, and we're going from the center. Let theta equal 0 represent the position of car 1 in the diagram from above, or the last page as it is in this case. Sketch the graph of the co-height and the height of the car as functions of theta, the number of radians through which the car has rotated. So the height we've always been talking about as the sine, so that would mean the co-height would be the cosine. So in looking at this, if I were to let theta equal 0, and I'm talking about the position of car 1, which is at 0 degrees on our diagram. Sketch the graphs of the co-height and car 1 as a function of theta. Okay, so the co-heights would be my cosines functions. So this would be my co-height. Actually, I want a little, I need to do that kind of a graph here. And the height off of the ground, we were told, was 15 feet from the ground or so. Plus there is, let's see here, 25, oh, we're starting at the 0. So it is, the diameter of the Ferris wheel is 50 feet, therefore halfway, the radius, because we're starting from the center, going to the measuring the radius, would be 25 feet. So I'd have a height of 25 feet. And that is my x value on the circle would be 25 feet away from the origin. And then at 90 degrees, which would be the top of the Ferris wheel, and 90 is pi over 2, we'd be at 0. And then at 180 degrees, we'd be at negative 25 feet because it would be going to the left of the origin. And then at 270, which is 3 pi over 2, we'd be back at 0. And then at 2 pi, we'd end up back at 25 feet at this origin. Or not the origin, but when we're back at 0 degrees. All right, so that's my co-height. The height would be my sine values, my y values. And when I start out at 0 degrees, I am not anywhere in the air. And then at 90 degrees, which is pi over 2, I'd be at 25 feet. And then at pi, at 180, again, I wouldn't be high at all. Be at the same place as I was when I started. Then at 3 pi over 2, which is 270, I'd be at negative 25 feet, because I'd be at the bottom of my circle. And then finally at 2 pi, I'd be back where I started from. So that would be mapping out the heights. So what is the amplitude A, the height and the co-height function? So the absolute value of A in this case is 25 feet. So x represents the co-height function, and we need to write an equation. Well, so x of theta is going to be, my amplitude is 25, and x represents the cosine, so 25 cosine theta, and y represents the sine values, because they're the heights of all of how far we are above and below the origin, so it would be 25 sine theta. All right, next page. We're actually not going to do this. Why did we choose the symbol x and y represent the height and the co-height of the functions? Because x is used to represent cosine, and y is used to represent the sine function. Okay? Evaluate x of 0 and y of 0 and explain their meaning in the context of the Ferris wheel. Well, x of 0 equals 25 times the cosine of 0. Well, the cosine of 0 is 1. 1 times 25 is 25. And this means we are 25 feet away from the origin. And then y of 0 is 25 times the sine of 0. And the sine of 0 is 0 times 25 is 0. So if that means we are 0 feet above the x-axis, so actually on the Ferris wheel, this means we are at car 1, which is 3 o'clock on a clock, if we think about it that way. It's at the 3 on the clock. Evaluate x of pi over 2 and y of pi over 2. So x of pi over 2, so I have to do 25 times the cosine of pi over 2, which is the cosine of 90. Cosine of 90 is 0, so this is 0. And y of pi over 2 is 25 times the sine of pi over 2, which is the sine of 90. It's just 1 times 25 is 25. So, I mean, this was the point 25, 0, and this would be the point, well, it's actually not the same graph, so we can't do that. Sorry, my bad, don't do that. This means that we are at the top of the Ferris wheel. All right, moving on. Okay, the model we created in exercise 1 measures the height car 1 above the horizontal line through the center of the wheel. Now we want to alter this model so that the measure is the height of car 1 above the ground. So now we have to include this distance here. If we measure the height above the height of car 1 above the ground instead of above the horizontal line, we go through the center of the wheel. How will the functions x and y need to change? So they originally told us that we were 15 feet above the ground, so this is 15 feet, and if this is 25 feet, that means my total distance is 40 feet. So if I just look at the graphs of the, let's see, oh, so just be, this should be 40 feet above the ground. For y of theta, x of theta is not affected. So x of theta will not change. So that means on my graph, this would be 25, this would be negative 25, and that's pi. It's pi over 2, 3 pi over 2, 2 pi. My graph is still going to look like this. This would be the co-heights. And then for my heights, now my midline has to move up to 40, and I have to go 25 feet above 40, which is 65, and 25 feet below 40, which is 15. So I'm going to start at 40, and then this is pi, this is 2 pi, 3 pi over 2, pi over 2. So pi over 2, I would reach the top of the Ferris wheel, so I'm at 65 feet, and then I'm going to come back down to pi, and then I'm going to come down to 15 feet, and then back up here. Pi, we're at 40 feet, sorry, my midline. Okay, so that's what that graph will look like. So how are the graphs from part B related to the graphs from exercise 1A? The co-heights don't change, but the height has been translated up 15 units, in this case 15 feet. All right, moving on. From this perspective, find the equations for x and y that model the position of car 1 with respect to the number of radians the car is rotated. So x of theta is not changing, so it's still 25 cosine theta. And y of theta, my amplitude hasn't changed, but we've translated it 40 units up. So this right here is our midline, which is our k value that we've been talking about in class. All right, we are not doing this one. You evaluate x of 0, y of 0. So x of 0 is not changing. It's still 25 times the cosine of 0. The cosine of 0 is 1 times 25 is 25. And y of 0 is going to be 25 sine of 0 plus 40. So the sine of 0 is 0 times 25 is 0 plus 40 is 40. And then evaluate x of pi over 2. So I'll have 25 times the cosine of pi over 2, which is 90. So the cosine of 90 is 0 times 25 is 0. And then I will have 25 times the sine of pi over 2 equals, so the sine of 90 is 1. Oh, sorry, I forgot my plus 40. So the sine of 90 is 1 times 25 is 25. 25 plus 40 is 65, which was the height on the Ferris wheel, which means I'd be at the top of the Ferris wheel. All right. So, in reality, nobody boards a Ferris wheel halfway up. Passengers board at the bottom of the wheel. To truly model the motion of a Ferris wheel, we need to start with the passengers at the bottom of the wheel. So we really need to start down here. Oh, sorry about that. So let theta equals 0 represent the position of car 1 at the bottom of the wheel on the diagram above. Sketch the graphs of the height and the co-height of car 1 as the function theta. Remember the radians through, or the number of radians through which the car is rotated from the position of the bottom of the wheel. Well, what I have to do then is, if I'm starting at just looking at my heights, I start at the bottom of the wheel, I'm at height 0. When I go a quarter of a turn or 90 degrees, I'm at 25 feet away from the origin, or away from that midline there. Well, it's actually not the midline, my vertical line where I started from. And then at 180, I'm back in line with where car number 1 is. I'm actually at car number 7. And then I have 3 pi over 2, so at 270, I'm to the left of where I started, negative 25. And then at 2 pi, after 360 degrees, I'm back to where I started from. And this is the co-height starting at the bottom. And then this is the height starting at the bottom. And my midline is going to stay at 40. My low value is going to still be 15, and my high value is still going to be 65 because I still have an amplitude of 25. Those things are not changing. Except if I'm starting at the bottom of the circle, I am at 15 feet above the ground. And then let's see, we have halfway is pi. So if I go a quarter of a turn, I end up in this diagram up above at car 10, which is at 3 o'clock, and I'm at 40 feet above the ground because I've done quarter of a turn. I've now gained 25 feet in altitude. And then at pi, halfway, I'm at 65 feet because if I go from car 1 to car 7, I'm now at halfway around, and I'm at the tallest point on the graph. And then if I go 270 degrees around, I'm back at 40 at the midline at car number 4. And then I need to get back to car 1, which is at 2 pi. So that is actually what my graph will look like if I started at the bottom. So how are the graphs from part A related to the graphs from exercise 2B? Well, the graphs are both translated horizontally pi over 2 units to the right. All right? You can compare your graphs if you need to. From this perspective, find the equations of the functions that we're modeling. Well, if I'm moving to the right, my amplitude is not changing. I'm going to do minus pi over 2. And y of theta is 25 sine theta minus pi over 2 plus the 40. And we're not going to do this one. Evaluate x of 0 and y of 0. So x of 0 will be 25 times the cosine of 0 minus, sorry, it's 0, not theta, 0 minus pi over 2. And if I were to take the cosine of, because 0 minus pi over 2 is negative 90, which is the same thing as 270, the cosine of 270 is 0 times 25. It's still 0. And then y of 0 is 25 times the sine of 0 minus pi over 2 plus 40. Oh, extra parentheses. So negative 90, because 0 minus 90 is negative 90. Sine is the same thing as 270. The sine of 270 is negative 1 times 25 is negative 25 plus 40, which is 15. And this means I'm at the bottom of the Ferris wheel. Now I'll do the same thing, just 90 degrees, and let's see where we are here. X of pi over 2 is 25 times the cosine of pi over 2 minus pi over 2. So the cosine of 0 is 1 and times 25. And then y of pi over 2 is 25 times sine of pi over 2 minus pi over 2 plus 40. So that's 0. The sine of 0 is 0 times 25 is 0 plus 40. So in the context of the Ferris wheel, I'm at 3 o'clock again, which is at 90 degrees after a 90-degree rotation. All right. So you are in car 1 and you see your best friend is car 3. How much higher than your friend are you when you reach the top? Okay, so we kind of got to think about this. When you're at the top, you're at 65 feet. Okay? So at car 1, you're at 65 feet. And your friend is in car 3, which is 60 degrees less than you have rotated. Okay? You've gone 180 degrees, or pi, because you're at the top of the Ferris wheel. So that means if your friend is 60 degrees less than you, they've rotated 120 degrees, which is 2 pi over 3 radians. So we have to use our sine value because we're talking about the heights. So we're going to use that equation. I'm going to do y of 2 pi over 3. So I will have 25 times the sine of 2 pi over 3 minus pi over 2 plus 40. So it'd be 25 times the sine of, well, 120 minus 90 is 30, which is pi over 6 plus 40. The sine of 30 is 1/2, so 1/2 of 25 is 12.5 plus 40, which means your friend is at 52.5 feet. So if you take your 65 feet and subtract his 52.5 feet, you will get 12.5 feet. So you are 12.5 feet higher than your friend in car 3. All right. We're actually going to stop right there. We're not going to do 5, and we're not going to do 6 or 7. There's some more things we need to talk about this. We have to add in the factor of time. And so in class, I will show you how we add in the factor of time, because if you notice, we've only dealt with A, H, and K. We haven't dealt with B, which is the period. So we need to discuss the period and how that affects these types of problems.